Kirchhoff's second law told us that around any closed loop in the circuit, the sum of the EMF is equal to the sum of the potential difference. So, in the circuit, we have EMF, electromotive force, and we have resistors. So, in this one, for example, this, okay, here. So, this one, it is a cell, it has electromotive force. One, okay. Another one, this is E2. And then we have a resistor. So it's like this. So this is R1 and this is R2. The current through this circuit is I. So we can say that the sum of EMFs, so it means E1 plus E2, the sum of EMFs, is equal to the sum of the potential difference. So the potential difference around R1, it's IR1. Potential difference around R2 is IR2. So we say it's equals to I1 R1 plus I2 R2. We can rewrite this in another form, that E1 plus E2 minus I1 R1 minus I2 R2 equal to 0. This means the energy is conserved. So this is called Kirchhoff's loop, because he said around any closed loop. So the energy in that Kirchhoff's second law, the energy is conserved, no loss of energy. So the sum of electromotive forces, the sum of EMFs, equals the sum of potential difference. Okay? So this law, in this law, the energy is conserved. In any circuit, in any circuit, the energy is conserved. Energy is conserved. Now we assume that in the circuit, we have a resistor and we have the cell. So we will agree for this one. If the current passes through the circuit, okay, this is a resistor, and we have 2 points, A and B. If the current passes from A to B, so we say it's negative IR. So if the current from A to B, so we say it's negative IR. What will happen if the current passes from B to A? It's also negative. So in case of resistor, if the current passes from A to B or B to A, we assume that it's negative IR. So from A to B or from B to A, it's negative IR. What about the cell? Because in the circuit, in case of Kirchhoff's second law, we will get a cell and resistor. So in case of in case of cell, this is a cell. So it has a positive and negative. The small one is negative and the big one is positive. We assume that the movement of electron is from negative to positive. So we assume that this is the positive direction of EMF. So if the current in the circuit passes from A to B, so if it is from A, this is the electromotive force. So if the current in our circuit passes from A to B, so from A to B, it is opposite to the movement of electrons inside the cell. So we say it's negative E, negative electromotive force. But if the current passes from B to A, we assume that it's a positive electromotive force. This is very important to solve the questions in Kirchhoff's second law. Let us see this question. It is in page 101, number 8. This is from past paper question. So he said, in that circuit, find out I1 and I2 if I3 equal to 3 ampere. Let us restart to solve. Actually, in this question, we use Kirchhoff's first law and Kirchhoff's second law. First of all, we can use Kirchhoff's first law. How to use that one? So, we choose a point. At that point, we have the 3 currents. Because in that circuit, we have 3 currents, I1, I2, I3. So, this point A or this point B. At these points, the 3 currents meet together. So we choose any one of them, A or B. For example, at the point A. So the solution of this question starts from this. So we say at the point A, we apply Kirchhoff's first law. The sum of currents in equals the sum of currents out. What about the currents in and out? Look, this is I3. This is the direction of I3. So I3, it's in. And this is the direction that are given. So we don't assume that I3 and I2 and I1 and that. No, this is a given in the question. So I1 out and I2 also out. So the current in is I3. The currents out are I1 and I2. So I3 equals I1 plus I2. This is Kirchhoff's first law. But I3 is given. He said I3 is 3 ampere. So we say I3 equals I1 plus I2. It means I1 plus I2 equals 3. Let this equation number 1. Now we have just 2 unknowns. So we need just 2 equations. This is the first equation. So we need another equation. We can get that equation by applying Kirchhoff's second law in loop 1 or loop 2. So we choose loop 1. So we say loop 1. Now, in loop 1, we start at a point and go in that direction. But before to do anything, we have to put the direction of electromotive force. So it's from small to big. So this is the direction. Now, okay, we can start from the point A. Start from the point A and go in this direction. So remember in that path it's I1. So this is I1. So I1 here it's I1. In this it's I1. Till the point B it's I1. But in that part of the circuit is I3. So here it's I3, and so on. Now, I1 here, no resistor here, but we have the electromotive force 6. So it's positive because it has the same direction as the loop 1. So we say 6. 3, the resistor is 3, and the current is I1. So the potential difference is the negative 3 I1. So it's a negative 3 I1. Now finish I1. Now I3. Okay, in that we have electromotive force. It is in the same direction of our loop, in the loop 1. So it is 3 positive. So it's positive 3 electromotive force. And this is the resistor, it's 2 ohm, and the current is I3. So it's negative 2 I3. Then stop at the point A. So the loop is closed. So the sum of this equal to 0. But I3 is given 3 ampere. So what we do, replace I3 by its value. I3 equal to 3 ampere. So we write 6 minus 3 I1 plus 3 minus 2 multiplied by 3 equal to 0. So 6 minus 3 I1 plus 3 minus 6 equal to 0. We simplify. Positive 6 and negative 6 cancel. Negative 3 I1 plus 3 equal to 0. Move 3 to the other side. So negative 3 I1 equals negative 3. Divide both sides by negative 3. So I1 equals 1 ampere. Take care. Because the direction is given, so all the answers must be positive. We found I1 equals 1 ampere. We need to get I2 because this is the required. Find I1 and I2. What we do? Substitute in equation 1. So substitute for I1 equals 1 in equation 1. So from equation 1, I1 now it's 1 ampere, I2 equals 3. 1 to the other side, it becomes negative, so I2 equals 3 minus 1, so I2 equals 2 ampere. So this is the answer. Let us receive this question in page 101, question number 9. This is from past paper question. He said, in that circuit, state Kirchhoff's second law. Around in a closed loop, the sum of electromotive forces, EMF, is equal to the sum of B potential difference. This is Kirchhoff's first law. The second part, calculate I2 and I3. Now, we calculate I2 and I3. For the second part, I2 and I3. First, we apply Kirchhoff's first law. We choose one point. At that point, we have the three currents. So, we can choose this point, point A, or this point, point B. Now, we check the direction of the currents. For here, at the point A, this is I2, so I2 it's in. And this is I1, I1 also is in. And I3 is out. So, at the point A, we apply Kirchhoff's first law. At the point A, the sum of currents in it's I1 and I2. So, I1 plus I2. The sum of currents in equals the sum of currents out. Just one current, I3. So, it's equal to I3. But here, we have given I1 equals 2 ampere, 0.2 ampere. So, it's given. So, replace I1 by its value to minimize the number of unknowns. So, I1 replace it by 0.2. So, 0.2 plus I2 equals I3. Now, we can say this equation number 1. We need another equation because just we have two unknowns, I2 and I3. So, we take this loop. Actually, in that circuit, we can form three loops. This loop, or this loop, or outside. Now we take this loop. Now take care when you use the loop. So this is a given direction, I1 and I3. So it's better to say the loop like this. So we can say this is loop 1. So loop 1. Okay, loop 1, it's a clockwise. The second, we put the direction of electromotive force in this way. So, from small to big. This is just one cell we have in that loop. So, we start from the point A. Okay, now, in that part of the circuit, we have I3. And the resistor is 20. So, it's negative 20 I3. And now, in that one, we have the voltage here, 16 volt. It's positive because it has the same direction of the loop. So, plus 16. Now, here, this is I1, and the resistor is R1. So, it's negative. So, negative I1, R1. Now, stop at the point A, so the sum equals 0. Kirchhoff's second law. Okay, already we have the value of I1. R1 also we have here. R1 it's a 2. So replace I1 by its value and R1 by its value. So negative 20 I3 plus 16 minus I1 it is 0.2 multiply R1 it's 10. So the sum of this equals to 0. Now negative 20 I3 plus 16. 0.2 plus 10 equals 2. So it's minus 2 equal to 0. Like term, 16 minus 2, it's positive 14. To the other side, it will be negative 14. So negative 20 I3 equals negative 14. 16 minus 2, 14. To the other side, negative 14. Divide both sides by negative 20. So divide by negative 20, divide by negative 20, cancel negative with negative. So I3 equals negative cancel with negative, simplify, divided by 2 equals 7, divided by 2 equals 10, it means 0.7 ampere. So I3 equals 0.7 ampere. We need to get I2 because this is a required. Find I1 and find I2 and I3. Already we got I3, so we need to get I2. Substitute in equation 1. So from equation 1, replace I3 by its value. So 0.2 plus I2 equals I3, 0.7. So move 0.2 to the other side. So I2 equals 0.7 minus 0.2. So I2 equals 0.5 ampere. We finish this part. So we solved the first part and the second part. Now let us see the third part of this question. What value of I1 would increase the power dissipated by R1 4 times? Now what is the power in the first case? So when I1 equals 0.2, R1 already equal to 10 ohms. What is the power? Which formula we use it for the power? V equals I squared R. The power now equals I squared times R. So it is 0.2 squared multiplied by 10. Use the calculator to get this answer. Answer is 0.4 watt. 0.4 watt. This is the power when I1 is 0.2 and the resistor is 10. He said what value of I1 would increase the power dissipated by 4 times. So now 4 times the new power, it's 4 times. So it's 4 multiplied 0.4 equals I squared. We need this value of I. The resistor is fixed. It is constant. It's 10. So multiply 10. From this we can get the new current. That goes, the power increases by 4 times. 4 multiplied 0.4. So I squared in this equation, we can simplify. So I2 squared is 0.16. So I equals the square root of 0.16. Square root of the answer, it is 0.4 ampere. 0.4 ampere. So the current must be increases by 0.2 because the old one is 0.2 and the new one it will be 0.4 ampere. So if the current is 0.4 ampere, the power increased by 4 times. We can solve this part in another way. B equals I squared R. Because R is constant, just we need a relation between the power and the current. So we say the power proportional directly to I squared. Then we can say B1 over B2 equals I1 squared over I2 squared. Now, when the current I1 equals, okay, but to don't confuse, we can say B1 and B1 dash, okay? So, to don't confuse between I1 and I2, so we can say B1 and B1 dash, I1 and I1, okay, dash squared. So, when I1 equals 0.2, the power B1 equals B. What is the new power, what is the new current, I1 dash, when the power is 4 times 4 the power. Now we do this here. So replace B1 by B, and I1 by 0.2 is squared over I1 dash is squared. This is the required. And B, it's 4B. What we do? We simplify. So divided by B, cancel, so it's 1 over 4, and do cross multiplication to get I1 dash. So I1 dash squared, so I1 dash square equals 4 multiply 0.2 squared over 1. You can get this one. It's 0.16. So I1 dash equals square root of 0.16. It is 0.4 ampere. The same answer, but another way. Let us we see this question. It is page 102, question number 11. Also, it's from past paper exam. He said, use Kirchhoff's law to calculate the following from the circuit shown below. The current I1 and I2, this is the first part of the question. The second, the resistance R. First of all, we use Kirchhoff's first law. It's better because it's easy. So now we take this point, the point A. So at the point A, now we check the current in and the current out. So this is the direction. So I2 is out. Also I1 is out. But 2 ampere is in. Okay. So the sum of currents in. So in just 2 ampere. So we say here 2 ampere. This is 2. The current in is 2. Out it's I1 and I2. So 2 equals I1 plus I2. This is equation number 1. We need another equation. So we use loop 1 or loop 2. Which one is better? Loop 2 we have a known R. So we can't solve. So we use loop 1 because just the unknown here is I1. But if we use loop 2, we will get 2 unknowns. So to get easier solution, we use loop 1. So we say loop 1. Now, start from the point A. We have here the current I1 and the resistance is 4. So it's negative 4 I1. Now, in this direction, take care. This is the positive of electromotive force. It is in the same direction of the loop, so it's positive 6. So plus 6, it's okay. So this is I1 plus 6, it's okay. Nothing else, just we have the current resistor and nothing here, just the electromotive force. So the sum equal to 0. Now it's easy to get I1 from this equation. Move 6 to the other side. So negative 4 I1 equals negative 6 divided by negative 4. So I1 negative 6 over negative 4. So it is 3 over 2. It means 1.5. So I1 equals 1.5 ampere. Now we can get I2. Substitute in equation 1. So from equation 1, I1 it's 1.5 plus I2 equals 2. Move 1.5 to the other side. So I2 equals 2 minus 1.5. So I2 equals 0.5 ampere. Okay, so we finish this part. We find I1 and I2. Now we need to get the value of R. Then we use the second loop, loop 2. So we go to the loop 2 because now in the loop 2, just we have one unknown R because I1 already we got it. So we use loop 2 now. Also we can start with this point. We go in this direction. Now follow me. What about here the current here? It's I1 and R and the 4. Okay. But before to do anything, we have to put the direction inside the cell. So now take care here. So this is I1 and 4. So it's a negative 4 I1. Negative 4 I1. Now, what about this resistor? Okay, take care. Because this is the current. This is the current here. The current is I2. It is opposite to our loop. It's opposite to. So take care for this. So we write it's minus. Okay. Because it has opposite direction, we add negative. And then inside the resistor, it's Ri2. So negative Ri2. Look, we have two sides. Why? Because in that case, the current I2 opposite to the direction of the loop. So opposite, it means negative. So in that value, we don't say minus I2R. No, we have to add another negative because that the current in opposite direction of the loop. Then the electromotive force, it's positive 3 because it's in the same. So plus 3 equal to 0. Okay, so negative 4 I1. Negative times negative, it's positive. R I2 plus 3 equal to 0. I1, 1.5. So negative 4 multiply 1.5 plus. I2 is 0.5. So 0.5 multiplied by I plus 3 equal to 0. We can solve this. The like terms are these one. So we use the calculator. They are negative 3. So negative 3 plus 0.5 R equal to 0. Move negative 3 to the other side. So 0.5 R equals positive 3 divided by 0.5. So R equals 3 divided by 0.5. 3 divided by 0.5. So the answer is 6. So R equals 6. It means R equals 6 ohm. Take care. If the direction of the current is given, the final answer must be positive. Also, R must be positive because it is a scalar quantity. I hope you understand this lesson. Thank you.